All right, question 1. A curve has equation y equals x squared plus 2x minus 3. Use the method of completing the square to find the coordinates of the stationary point on the curve. All right, well, I think completing the square should be relatively simple. So what do? We take the coefficient of x, which in this case is the number positive 2. We divide it by 2, which gives us 1. And then we can write x plus that 1 all squared minus that 1 squared. And of course, we've still got the minus 3, right? So just to clarify, you take the coefficient of x, which is 2, you divide it by 2, which gives you 1, and then you write x plus 1 squared minus the 1 squared. And if we were then to complete this, simplify it, we get x plus 1 all squared minus 1 minus 3, which is minus 4. Okay, now we want to identify where the stationary point is, and hopefully you can remember that if we've got a curve of the form x minus a all squared plus b, then the vertex, or the stationary point, is going to be at the coordinates a comma b, right? So there's an issue here that students forget, which is this is x minus a here, gives you the x coordinate of the vertex as being positive a. So in this particular case, right, this is like x minus minus 1. So the stationary point, or the vertex, is going to have an x coordinate of negative 1 and a y coordinate of negative 4. Okay, so that's going to be the end of part A. Part B, on the axes, we want to sketch the curve stating the intercepts with the coordinate axes. So we want to know where it cuts the x and y axis. So how are we going to do that? Well, an x-intercept is when y is equal to 0. So we are trying to solve 0 is equal to x squared plus 2x minus 3. And so the best way to do that is just to factorize it. So we've got x plus 3 and x minus 1, which gives us two solutions. X is equal to negative 3 and x is equal to positive 1. So those are going to be the two x-intercepts. The y-intercept is going to be where x is equal to 0. So we can just substitute that in. Y is equal to 0 squared plus 2 times by 0 minus 3, which is obviously negative 3, right? So we can now indicate this on our graph. So let's kind of do it like this. So we've got 1, 2, 3, I guess. 1, 2, 3. What was it? Negative 3 and positive 1. So negative 3, positive 1, y-intercept at negative 3. Which I won't put it to scale, just put it there, right? So that's negative 3. So we want to indicate that our curve is going to go through that point, and that point. And we probably also want to use the fact that we learned that the vertex is at negative 1, negative 4, right? So negative 1, negative 4. So I guess kind of put that there-ish. Okay, and there. And so now we want to kind of join up the dots. So I'll try to do this as best I can, make it a smooth curve. Something like that. Like that. Okay. Okay, yeah, it should be good enough. Okay, and so therefore we've got our quadratic. We've indicated where the vertex is, the stationary point. We know the x-intercepts and we know the y-intercepts. And that should be enough for the 2 marks. In this question, k is a constant. It is given that 2x squared plus 3k minus 2x plus k equals 0 has roots that are real and distinct. Find the set of possible values of k. Okay, so this is a quadratic discriminant question. And we'll just quickly revisit the theory of that, right? So if we've got a quadratic of the form ax squared plus bx plus c is equal to 0, then the discriminant is b squared minus 4ac. Now, why is that? Well, because we know that the solution to this quadratic using the quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. So in other words, the solutions are going to be dependent upon this term here, the b squared minus 4ac. Why is that? Well, let's have a quick think. If b squared minus 4ac is negative, then we're going to have to square root a negative number. Now, we can't square root a negative number, or at least we can't at the moment. And so if this value is negative, it means that we are going to have no real solutions, no real roots. Okay? On the other hand, if this value for b squared minus 4ac is 0, then what we're going to get is we're going to get minus b plus 0 divided by 2a, and then minus b minus 0 divided by 2a. And of course, those things are the same thing, right? It's minus b upon 2a. So we would have real solutions, but those real solutions would not be distinct, right? They would be the same thing, be identical. But then on the other hand, if b squared minus 4ac is a positive number, then we can square root it, so that's fine. And let's say it's like positive 4. Then what we would get is we get minus b plus the square root of 4 upon 2a, and then minus b minus the square root of 4 upon 2a, and those would be two different answers, two distinct answers. So if we want roots that, if we want no real roots, this thing here needs to be negative. If we want two identical roots, this thing here needs to be 0. And if we want two distinct different roots, then this thing here needs to be a positive number. So in this particular question, we are told that roots are real and they are distinct. So in other words, what we require is that the b squared minus 4ac must be a positive number. In other words, it must be greater than 0. And in this case, what is b? Well, the b is 3k minus 2. So we've got 3k minus 2 squared. What's our a? Our a is 2. And what's our c? Our c is k. So we require that this whole thing here is greater than 0. So now we're basically just going to get a quadratic and we can solve it. So let's expand the bracket. So we'll get 9k squared. 3k times negative 2 is negative 6k. And I've got two of them, so that's negative 12k. Negative 2 squared is positive 4. And minus 8k. We want that to be greater than 0. So that gives us 9k squared minus 20k plus 4 is greater than 0. And unfortunately, those numbers we can't divide through to simplify. So we just got to factorize as we can. So we're going to get two brackets. Now, if we've got 9k squared, there are two ways we could do that, right? It could be 3k and 3k. Or it could be 9k and 1k. So why don't we try that first, 9k and 1k. And we want two numbers that will multiply together to give 4, but are going to combine together to give negative 20. So both those numbers are going to be negative. And I suspect if we do negative 2 and negative 2, that's going to work, right? Because negative 2 times negative 2 is positive 4. 9k times negative 2 is negative 18k. And then minus 2k is negative 20k. So that works. Now, at this point, the classic error is for students to go, oh, okay, 9k minus 2 is greater than 0, so k is greater than 2 upon 9. And also k minus 2 is greater than 0, which means that k is greater than 2. And most students will do that, and they will lose a mark. So we don't want to do that because that's wrong. Instead, the best thing that we can do, I think, is we actually just want to sketch this quadratic out, because if we sketch it out, we can really clearly see what's going on. So what will my quadratic look like? Well, we know that we have got intercepts, x-intercepts at 2/9, that's one root, and the other one's at 2. So if I was to sketch out this quadratic, then the quadratic's going to look something like this. So oh, not so good there, but I'm doing my best. Okay, like that, like that, like that. Okay, so this is the quadratic of, I can write it down as y is equal to 9k squared minus 20k plus 4. Now the question is, when is this quadratic greater than 0? Well, it's got to be greater than 0, right? When it's above the x-axis, or the k-axis in this case, or when the y values are positive, right? So if we want this quadratic to be positive, we want these values here to be positive, the y values to be positive, to be above the x-axis. So we are interested in this part of the curve and this part of the curve. Well, what values of k give us these two parts of the curve? Well, either k is greater than 2, so everything there to the right, or it's less than 2/9, right? Everything there to the left. So my final solution should be that k is going to be less than 2 upon 9, and also that k is going to be greater than 2. Right? So those are going to be my final solutions. And the way I can get that most clearly is by paying attention to what the graph looks like. All right, question 3. A sports club has the following members, 5 runners, 4 swimmers, 3 gymnasts, these members stand in a straight line. Okay, so we've got 12 people in total. They all stand in a straight line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And find the number of ways that this can be done when all the runners stand together, all the swimmers stand together, and all the gymnasts stand together. Okay, well, got 5 runners, so we could have 5 runners as one group there. And then we've got swimmers, 4 swimmers, so 4 swimmers there. And then we've got the 3 gymnasts like that, right? So how many ways can we rearrange these guys? Well, first of all, we can treat them as 3 big groups. So we've got a group here, a group here, and a group here. So we've got 3 groups. And how many ways can we arrange 3 groups? Well, it's 3 factorial, okay? And then what we can do is we can look inside each group, right? So here's the group of runners. Well, how many ways can we rearrange 5 runners? That would be 5 factorial. And then how many ways can we rearrange the 4 swimmers? That'd be 4 factorial. And how many ways can we rearrange the 3 gymnasts? That'd be 3 factorial. And notice that we're multiplying all of these together. Why is that? Well, because for each of the 3 factorial ways of arranging these big items, there are 5 factorial ways of arranging the runners, and there are also 4 factorial ways of arranging the swimmers and 3 of the gymnasts. So if I was to draw it out as a diagram, right? So there are 3 factorial ways of organizing the big items. That's like a total 6 ways. And then for each of those, there are 5 factorial ways of arranging the runners, right? So for each of these, there's like 5 factorial ways of arranging the runners. And then for each of those ways, there are 4 factorial ways of arranging the swimmers. So we can imagine just a tree diagram which just extends and extends and extends, so that what we've got is 3 factorial times the 5 factorial times by 4 factorial times by further 3 factorial. And if we do all of that, if we multiply out everything together, then we get 103,680. All right. Okay, so let's try the next one. So 4 of these members are selected for an event. Find the number of ways that this can be done when at least 1 runner, at least 1 swimmer, and at least 1 gymnast must be selected. Okay, so let's split this up into groups. So we've got runners, swimmers, and gymnasts. Okay, and we want a group of 4. So let's say that we started off with just 1 runner. And then we also had 1 swimmer. Well, how many gymnasts would we need? We would need 2 gymnasts. Okay, so actually every single variation is going to be a group of 1, a group of 1, a group of 2. So what's the other alternative? Well, I could have 1 runner, 2 swimmers, and that means I'd have 1 gymnast. Or I could have 2 runners, 1 swimmer, and 1 gymnast. Okay, so now I've got to ask myself the question, well, how many ways could I choose 1 runner? Well, there are 5 runners to choose from, so that'd be 5C1, right? I'm choosing 1 runner out of 5. And how many ways could I choose 1 swimmer? Well, there are 4 swimmers, so that would be 4C1. And how many ways could I choose 2 gymnasts? Well, there are 3 gymnasts to choose from, so that would be 3C2, right? I'm choosing 2 out of 3. And what have I got to do? Well, I've got to multiply all these. Why am I multiplying them? Because basically, I want 1 runner, and I want 1 swimmer, and I want 2 gymnasts, right? So every time I've got this and this, so 2 events together, I need to multiply, okay? So I'm multiplying those events. But then what I've got, right, is I've not only got this case, 1 runner, 1 swimmer, and 1 gymnast, this case, I've also got to consider this separate case, right? So it could be this, or I could have this case, right, which is 1 runner, 2 swimmers, and 1 gymnast. So how many ways could I choose 1 runner? Well, that would be 5C1. How many ways could I choose 2 swimmers? 4C2. And how many ways could I choose 1 gymnast? That'd be 3C1, right? And again, what do? I multiply them, right? Because it's 1 runner and 2 swimmers and 1 gymnast. So I multiply. But then I've got another alternative, right? So I could also have this case. So it would be or this case here. So how can I choose 2 runners? Well, that'd be 5C2. And how could I choose 1 swimmer? That'd be 4C1. And how could I choose 1 gymnast? That'd be 3C1. And again, I multiply those together because it's 2 runners and 1 swimmer and 1 gymnast. So I multiply. So I've got these 3 cases to consider. Either this case, or this case, or this case. So what do? I add up all of the different cases. So when I've got one case or another case, then that means I add up. So let's try to calculate what this all is. Right, so 5C1 is 5. Ooh. 4C1 is 4, and 3C2 is 3. 5C1 is 5. 4C2 is 6, and 3C1 is 3. And 5C2 is 10. 4C1 is 4, and 3C1 is 3. So if I multiply out all of these guys, then I've got that's 60. That's 90. And this guy is 120. And if I add up all of those, 60 plus 90, so that's 150, plus 120 is 270. And so my end answer is going to be 270. All right, so here we are in question 4. The coordinates of points A, B, C, and D are as follows. So it's these points here. The line L has this equation, y equals 11x minus 75. And the perpendicular bisector of the line AB meets L at the point E. We want to find the area of the triangle CDE. Now, I know a lot of students do not like doing this, but I really think it is extremely helpful to have a clear sketch of all the points. You can't get marks for accurate drawing, right? So this is not to give you marks, but it is to help you to understand what's happening in the problem so you can visualize what's going on. I really think it's very important. Now then, let's peel back. We've got this line, right? So 11x minus 75, and it's going to be intersecting another line at the point E. Okay, so this other line is the perpendicular bisector of AB. Well, what is the perpendicular bisector of AB? Well, here is the line AB in blue, and the perpendicular bisector, well, perpendicular means 90 degrees, right? So it's going to be running 90 degrees to this line, and bisect means to cut in two. Right, so it's going to be cutting through the midpoint, right? So we've got the midpoint here. So we want to find the equation of this line that is perpendicular to AB and that goes through the midpoint of AB. So we want to find those two things first. So how do we find the midpoint of AB? Well, we add up the two x coordinates and divide by 2. So we've got -4 plus 6, and we divide by 2. And we add up the two y coordinates, so it's 3 plus -9, and we divide by 2. And -4 plus 6 is 2, divided by 2 is 1. And 3 minus 9 is -6, divided by 2 is -3, right? So the midpoint of AB, this guy here, is 1, -3, and that looks about right on my sketch, so that's good. And then I want to find the gradient of my perpendicular bisector. Well, how will I do that? Well, I'll find the gradient of AB first, and then the negative reciprocal of that will give me the gradient perpendicular, the gradient of the green line. So the gradient of AB is y2 minus y1, so -9 minus 3. So we get -9 minus 3 over x2 minus x1, so that's 6 minus 4. Well, -9 minus 3 is -12. 6 minus 4 is 6 plus 4, which is 10. So the gradient of AB is -6/5. And the gradient perpendicular to that will be the negative reciprocal. So we got -1 divided by -6/5, which is +5/6. So now we've got the gradient and we've got the coordinate point. We can find the equation of the perpendicular bisector by using the formula, right? So y minus y1, so y minus -3 is equal to m, which is 5/6, x minus x1, so x minus 1. So we've got y plus 3 is equal to 5/6 of x minus 1. Okay, now what are we told? We are told that this line is going to intersect some other line, right, 11x minus 75 at the point E. So how do we find the intersection of two lines? Well, we solve simultaneous equations. So we've got, to solve the simultaneous equation of y equals 11x minus 75 with this equation for the perpendicular bisector there, right? So we'll call that equation 1, call that equation 2, and I think the easiest thing to do is to substitute equation 2 into equation 1. So how will we do that? Well, we will write 11x minus 75 plus 3 is equal to 5/6 of x minus 1. So simplifying this, we've got 11x minus 72 is equal to 5/6 x minus 1. And I think I'll multiply both sides by 6. So 11 times 6 is 66. I've got to do 72 times by 6. Well, I don't have my calculator on me, so I'm going to do that over the side here. 72 times by 6. So 6 times by 2 is 12. 6 times by 7 is 42. So 2, 3, 4. So 432 there. So that's minus 432 is equal to 5 times by x minus 1. So it's 5x minus 5, I think. And let's just rearrange that. So I think that's going to be 51x. If I add 432 to both sides, what's that going to be? That's going to be 427, I think. And, oh, sorry, that's 61, isn't it? Not 51, 61. And of course, then I'd have to do 427 divided by 61. Now, I don't have a calculator again, so that's kind of annoying, but I suspect that's going to be 7, isn't it? And the way I know that is because 7 times by 60 is going to be 420, right? Because 7 times 6 is 42, and then obviously 1 times 7 is 7. So that works. Okay, so we got x, and then we want to find y, isn't it? So I don't know. Y is equal to 11x, isn't it? So 11 times by 7 minus 75, was it? Let me just double check. Yeah, 11x minus 75. So that's going to give us 77 minus 75 is going to be 2. So the point E is the coordinate 7, 2. So I think I'll indicate that now on my diagram. So 7, 2. Where's that going to be? 2, 4, 6, 7, 7, 2. Don't know, something like that. So E is the point 7, 2. All right then. Now we want to find the area of the triangle CDE. So CDE, CDE. So what's that going to be? Where's C? C, D, E. Okay. Now, in order to do this, I think probably what we want to do is want to use the shoelace method or the shoestring method. How do we do that? So area. Well, we take a half of, and then we enter in the coordinates as column form going anti-clockwise around our shape. So we're going to start here with the coordinate 7, 2. So I put in the coordinate 7, 2 like that. And I go round to the next coordinate, which is 14, negative 1. So that's 14, negative 1. And around to the next coordinate, which is 15, 10. But then what I need to do, better write that a bit more neatly, otherwise I'm going to end up in trouble. 15, 10. Is I need to take the first coordinate and to write it down again. So the first coordinate was 7, 2. So I'm going to write down 7, 2 again. Okay. Now the shoelace, I multiply all of those pairs and I add them up, and I subtract off multiplying these pairs and adding them up. Okay. So let's just try to do that. So I've got half of. So firstly, I have got 7 times negative 1 is negative 7. 14 times by 10 is 140. And 15 times by 2 is 30. So that's the first one. Minus, let's do the red pairs. 2 times 14 is 28. Negative 1 times by 15 is negative 15. And 10 times by 7 is 70. Okay, so that's everything there. So now let's try to simplify all of this. So I've got a half of, oh my word, what is this? So I'll keep that as negative 7 for the moment. 140 plus 30 is 170. Okay, minus, so we got 28 minus 15. What's that going to be? That's going to be 13, isn't it? And then plus 70 still. Okay, so let's keep on that. So a half. All right, so we've got negative 7 plus 170 minus 13 minus 70. Sorry that the working's getting a bit bunched up here. I do apologize for that. So half of negative 7 minus 13 is minus 20. 170 minus 70 is 100. So negative 20 plus 100 is 80, and 80 divided by 2 is 40. So I get that my answer there is 40. And what I'm going to do is I'm just going to hold my breath and I'm going to check the mark scheme. And the mark scheme says it's correct. It is 40. Okay, so yeah, so that's how you do that. Now notice how I break down the problem, right? I think about it first as finding the equation of the perpendicular bisector, which means I've got to find the midpoint, which means I've got to find the gradient of AB, and I've got to do the negative reciprocal of that. Then I say that I need to find the intersection of the bisector with the other line. And then at the end, I need to do the shoestring method for the area. So a big part of these problems is you need to recognize for yourself all of the different steps, right? You're not told to do the steps, right? It's not like part A, do this, part B, do this, part C, do this. But you need to map out for yourself that you need to do each of those steps. So that's really the core skill here. Second thing is, right, actually, you don't really need a calculator to do this, right? I did it without a calculator. And can I just encourage you, as much as you can, try to do as many of the problems without a calculator, because the stronger you get with your mental arithmetic, with your long multiplication, long division, all of that, actually it's going to have a carry-on effect into your other math, your other ability. You'll just get much more stronger and much more confident. So by all means, obviously in the exam use a calculator, but as you're practicing, try to exercise those muscles a little bit, and I think you'll find it very helpful. Okay then. So we've got question 5. Given that y is equal to x squared times tan x upon 2, use calculus to find the approximate change in y as x increases from pi by 3 to pi by 3 plus h, where h is small. Now, we need to recognize that this is an approximate change question. And in order to do this question, we need to use the formula delta y upon delta x is approximately equal to dy dx, which is the first derivative, calculated at our starting point. I'll call that starting point, point A. Okay, so if you see approximate change, you're going to have to use this. Now, most of my students don't really understand where this comes from, so I'm going to take a tiny bit of time just to explain it. So if you feel like you already know, just you can skip ahead, but I'm going to do this for the benefit of the students who I think don't know. So let's imagine that we've got a curve, right? So I'll just draw a curve on like that. Okay, and let's say that curve is y is equal to, I don't know, x squared plus 1, for example. And we got 2 points on this curve. So let's say we've got here point A. And let's say that point A is just calculated when x is 1. And point B, which is a little distance along, right, is here. Now, if point B is a little distance along, then I can say that the change in x can be denoted by delta x, right? So delta x means a little bit of x, right? So I've moved a little bit of x in that direction. So this coordinate here is going to be 1 plus delta x. And similarly, right, if I've moved across a little distance in x, then what would this little distance in y be? Well, I could choose to write that as being delta y. Okay, so delta y is a little change in y. Okay, well then, if that's the case, right, then I can say that the gradient that takes me from A to B, let me try to do that a little bit better, right? So I'll write that there, the gradient of AB, that's going to be equal to delta y divided by delta x. Okay then, well, we could also imagine drawing another line, which is the tangent to A, like that, or the tangent to the graph at the point A, right? So that green line there is the tangent to the curve at the point A. So that green line, the gradient of that green line is going to be equal to dy dx, right? Because if we differentiate the curve, that gives us the gradient of the tangent, and it's specifically the gradient of the tangent at that point A. Now the thing is, right, if the point B is actually really, really close to A, then the gradient of that red line is basically going to be the same as the gradient of the green line, right? They're going to be really, really close. So in other words, delta y upon delta x is going to be equal to dy dx, the gradient of the tangent, at the point A. So I can just skip right ahead and say delta y upon delta x is approximately equal to dy dx calculated at point A, which is the point where x is equal to 1. So of course, you know, if I differentiate x squared plus 1, I think you all know that's going to give me 2x, isn't it? So that would be 2x. And calculated when x is equal to 1. And of course, if x is equal to 1, then 2 times by 1 is just 2. Okay, so the approximate change in y divided by the approximate change in x is roughly equal to 2. And let's say that, you know, the distance I moved along in the x direction, let's just say it's like 0.1, right? So delta x is 0.1. Then I could say something like, okay, delta y divided by 0.1 is roughly equal to 2. Therefore, the change in y is going to be approximately equal to 0.2. Okay, and that's actually right, isn't it? Because if we just take this, let's say this is the coordinate 1.1, right? Then what's 1.1 squared? That would be 1.21 plus 1, so that'd be 2.21, right? So we would go from this coordinate here, which is coordinate y coordinate 2, up to 2.21. Well, what's the rough change in y? Well, it's roughly 0.2, isn't it? It's exactly 0.21, but it's roughly 0.2. So we can see this thing works. All right, well, then we need to do it with this guy. So what's our strategy got to be? Well, we've got to differentiate this, right? And then substitute in when x is pi by 3. So let's go down, or I'll go across, I think. So x squared times by tan upon 2. So y is equal to x squared times by tan of x upon 2, big fun, or a half x. And how are we going to differentiate this? Well, we've got two functions multiplied together, right? We've got one function here, which is x squared. We've got another function there, which is tan a half x. So I'm going to call this u, and I'm going to call this v. And what we've got is the product rule, right? Because we've got the product of two functions, one function multiplied by another function. And hopefully you know that the product rule is v times by du dx plus u times by dv dx. So I've just got to differentiate and substitute in. So my v is tan a half x times by du, which is 2x, plus u, which is x squared, times by dv. Well, if I differentiate tan, I get sec squared. So it's sec squared a half x. And I've got to differentiate a half x, right, because this is a chain rule, and I get a half there. Okay, so, well, beg your pardon, I meant to write that's y prime, isn't it? So we've just differentiated this. Okay, so our starting point is when x is equal to pi by 3. So when x is equal to pi by 3, then y prime, or dy dx, we're just going to substitute in now, so we're going to get tan of pi by 6 times by 2 times by pi by 3 plus pi x squared, so that's going to be pi squared upon 9 times by sec squared pi by 6 times by a half. Now, of course, you've got calculators, right? But it's a good thing to know these critical angles, right? Pi by 6 or 30 degrees. And I'll do that with you as well. So the way to memorize these angles is you've got an equilateral triangle, right? So equilateral triangle, all the angles are 60 degrees or pi by 3. And let's say that we carve that into 2. So we divide that into 2 like that. And then we're free to set the lengths of our triangle as we choose. Well, I'm going to choose that length to be 2, which means that length's going to be 1 because it's a half of one side length. And then what's the height of this thing going to be? Well, by using Pythagoras theorem, that's going to be root 3, right? Because 1 squared plus root 3 squared is equal to 2 squared. And of course, if I cut this angle in half, as I did earlier, then that's going to be a half of 60 degrees or a half of pi by 3, which is pi by 6 or 30 degrees. So using this, right, I can find out what sine of pi by 6 is, because it's going to be opposite over hypotenuse, or cos pi by 6, which is adjacent over hypotenuse, or tan pi by 6, which is opposite over adjacent. Well, I need to know what tan is. So tan pi by 6 is opposite over adjacent, 1 upon root 3. And I need to know what cos pi by 6 is, right, because sec is 1 divided by cos. And that's going to be adjacent over hypotenuse, root 3 upon 2. Okay, so if I was to substitute this in, we've got tan pi by 6, which is 1 upon root 3, times by 2 pi upon 3, plus, I'll multiply, oh no, I'll just keep it as is, pi squared upon 9. Okay, so sec is 1 divided by cos, right? So if cos is root 3 upon 2, sec is going to be 2 upon root 3. And then we've got to square that. And then we've got to times it by a half. Okay, so let's keep simplifying. 2 pi upon 3 root 3 plus pi squared upon 18 times by, square that out, 4 upon 3, which is going to be 2 pi upon 3 root 3 plus, let's cancel a little bit, so 2 pi squared upon, so the 18 cancels, give 9, and 9 times by 3 is 27. Now you're probably thinking, you know, why are you doing all of that? I have a calculator and my calculator can do all that for me. Look, firstly, you should try to, definitely whilst you're practicing the papers, right, you should try to build up your confidence with your arithmetic. So you need to be developing that kind of skill. You also need to be getting confident in knowing these critical angles and knowing where they come from. But the other thing I would say is, for the students who just try to type in everything on one line on their calculator, they're taking an enormous risk. And the risk is that you type in everything absolutely correctly. And in my experience, you usually go wrong. So what I would do is I would do it step by step by step by step, simplify, 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 until you get down to the last line. And then if you like, you can type into your calculator. And I believe if you type that into your calculator, you'll get 1.94. 1.94 to 3 significant figures, right? 3 significant figures. Okay, also the other thing is, right, you don't know actually that your calculator is going to work on the day of the exam, right? It happens to everyone, well, not to everyone, but it does happen often that your calculator, for whatever reason, battery dies, black screen, whatever. So you want to be able to have the skill so you're not stressed out so much in the exam. Okay, so lastly, delta y upon delta x, and in this case delta x was h, I think, is approximately equal to 1.94 now. And so therefore delta y is going to be approximately equal to 1.94 times by h. And that should be your answer. And I'll just very quickly check that mark scheme, I think. Where have I got? 1.94h, that's correct. Okay, question 6. Using an appropriate quadratic factorization, find the first 3 terms in the binomial expansion of this whole thing in ascending powers x. Well, they've given you the clue, using an appropriate quadratic factorization. So we want to rewrite 9x squared plus 12x plus 4. And I think that that should factorize to be 3x, and 3x would be my guess. And I think 2 and 2. We can just double check that, right? 3x times 3x is 9x squared. 2 times by 2 is 4. And 3x times by 2 is 6x. And another 6x gives us 12x. So actually, this guy can be rewritten as 3x plus 2 all squared. Now, if that's the case, right, then actually what we're trying to do, if we're trying to do 9x squared plus 12x plus 4 all to the power of 5, then what we're trying to do is we're trying to do 3x plus 2 squared to the power of 5, right, which is going to be to the power of 10, right, because the power of 2 and then power of 5 is power of 10. So we've now got to do binomial expansion of this, and I'm going to rewrite it, I think, as 2 plus 3x to the power of 10, because we want this in ascending powers of x. So what does that mean? Well, it means the powers of x have got to increase. So 3x, firstly to the power of 0, then 3x to the power of 1, and then 3x to the power of 2. And then the powers of 2 will decrease, right? So 2 to the power of 10, 2 to the power of 9, 2 to the power of 8. And then we're going to have our coefficients, which will be 10c0, 10c1, or 10c1, and 10c2. Now, if you've seen me do this before, then you'll notice that I always write it out like that, because I find it's much easier to do it that way than to write this out, then write that out, then write that out, because the binomial expansion follows a pattern, right? Powers of one of the terms increase, 0, 1, 2. Powers of the other decrease, 10, 9, 8. The power should always add up to 10, right? So 10 plus 0 is 10, 9 plus 1 is 10, 8 plus 2 is 10. And then you can remember the coefficient terms. And if you want to be precise, actually this carries on, doesn't it? So dot, dot, dot. Okay, so now we're going to try to simplify this again. You're probably asking yourself, why are we not using the calculator? Well, we want to practice again without calculator. 10C0 is 1 because anything C0 is 1. You should hopefully know that. 2 to the power 10, well, you can actually calculate it on your fingers, right? You just go along your fingers. So start with 2, double it, 4, 8, 16, 32, 64, 128, 256, 512, 1024. Right, so I think that should be doable. And then 3x to the power 0 is 1 because anything to the power 0 is 1. Next, 10C1 is 10. And the reason for that is anything C1 will give you that number, right? So 8C1 is 8, 9C1 is 9, 10C1 is 10. 2 to the power 9, well, it's going to be half of that 1024, so that's 512. And we've got 3x there. Okay, next one. So what do we got? We have got 10C2. The formula for that is 10 factorial over 2 factorial, 8 factorial. I'll come back to that in a second. 2 to the power 8, that'll be 256. And 3x squared is 9x squared, because 3 squared and then the x squared. Okay then, so 1 times 1024 is 1024. And then we've got 10 times 512 times by 3. Well, 500 times by 3 is 1500. 12 times by 3 is 36. So it's 1536, I think. And then times by 10 again. So we get that. And 10 factorial divided by 8 factorial is just going to leave us with 10 times by 9, which is 90. And then 90 divided by 2 is 45. So we've got 45 times 256 times by 9 times by x squared. Now, I think that last term is just a little bit too ridiculous to do in my head. But if your calculator didn't work right, then what could you do? You could just do it with long multiplication. And I get, if I do that, 103,680. I think that's it. 680 x squared. Sorry, I missed out the x there, didn't I? Missed out the x there. That was a bit naughty. Okay, so I think that should be all of our terms. Okay. Okay, then part B, find the term independent of x in the expansion of this thing. What does independent of x mean? It means there are no x's, it's just a constant term. The way to approach these is again just to recognize the general form of each term in a binomial expansion, which is going to be, you're going to have 6 upon x squared to some unknown power, times by x to the power of 4 over 2 to some unknown power, and then that's going to be pre-multiplied by a coefficient term, which will be 12c something, where that something is either this power or that power. Now, what do we know? We know that the two powers here need to add up to 12, right? So the two terms must add up to 12. So it could be 12 and 0, 11 and 1, 10 and 2, and so on. But they also need to be chosen in such a way that these x terms are going to cancel each other out, right? So we want to choose the numbers so that the x's are going to cancel each other out. Well, I mean, if we chose, let's say we chose, I don't know, 1 and 11, right? This is going to be x to the power 2, and that's going to be x to the power 44. And that's not going to cancel out, right? So we want to try to get it so that the kind of the power of x on the top here is going to be the same as the power of x on the bottom, so they cancel out. And I think with a little bit of trial and error, you should see that that will be 8 and that will be 4. Okay, so that'll be 8, that'll be 4. Why is that? Because that will give us x to the power of 16, and this will give us also x to the power of 16, and so cancels off. And this guy here, it can be either 4 or 8. Let's choose 4. So, so here's our term. So let's now try to simplify this. So we've got 12c4, which is 12 factorial upon 4 factorial, 8 factorial. We've got 6 to the power 8 over x to the power 16 times by x to the power 16 over 2 to the power 4. And of course, the x to the power 16 cancels. And, you know, to be honest, it probably just is easier just to whack this all straight into a calculator at this point, because I think it's going to be like ridiculously big. So let's just stick it into a calculator, and that is 51,963,120. My goodness. Now that the Cambridge guys, right, have split this into calculator and non-calculator paper, they really are like having absolutely ridiculous numbers. But never mind. Is that the answer? Let me just double check. Yeah, 51,963,120. So that's the answer. Okay. Now, if you weren't sure about how to choose these numbers, by the way, let's just take a step back for a second. What could you do? Well, you could say, I'm going to let this number here be, I'll call it R. And therefore, this has got to be 12 minus R, right? Because the two things have got to add up to give me to give me 12. So what does that mean? Well, I want this power at the bottom to be the same as that power. So this power here will now be 2R, right? Because I've got x power 2 to the power r is 2R. And I want that to be the same as this power here. And that's going to be 4 times by 12 minus r. So if I was to expand that, I get 48 minus 4r. So 6r is equal to 48. And so therefore r is going to be equal to 8, right? So again, what would we get? We would get that the first power is 8, and then the second power would be 12 minus 8, which would be 4. So if you don't feel too confident in just using trial and error, you could also do it that way. Okay, then question 7. The function f is defined by 2e to the negative x plus 3 for all the real numbers. On the axis, sketch the graph of f of x, and hence on the same graph, sketch the graph of the inverse function. Show clearly the positions of any points where your graphs meet the coordinate axis and the positions of any asymptotes. I think it's probably just helpful just to indicate what the exponential graph basically looks like, right? So the basic exponential looks like that. Okay, that's y is equal to e to the x, and it will have a y-intercept at 1. And it has a horizontal asymptote for the x-axis. In other words, as x gets really small, right, so negative infinity, it approaches a value of 0. So it approaches the x-axis. What would e to the negative x look like? Well, it's a reflection in the y-axis. So e to the negative x looks like that. Okay, so that's y is equal to e to the negative x. And you just think about it, right? We basically switched x with negative x. So as x gets really big, this becomes actually like a negative really big number. And as that becomes a negative really big number, we tend towards 0. Okay. And what happens, for example, if we had y is equal to 2e to the negative x? Well, what ends up happening is that the 2 is a stretching of that. Okay, so the stretching of that is that we kind of double every single value of y. So obviously for the asymptote, because that's close to 0, if you double 0, you're still at 0. So the asymptote there would remain unchanged. But if I was to double the y coordinate, and which is 1, I would get to 2. So I would get to 2 there. So that would look like this. So that comes down like that. All right, but now if I'm going to shift everything up by 3, then everything goes up, including the y-intercept, but also the asymptote. So the asymptote is no longer the x-axis, it's the line y is equal to 3. So if I'm going to sketch all of this, then what I get is the following. So I am going to get, going through y is equal to 3. So 1, 2, 3. And going up to x-intercept of 5. So I'm just going to kind of try to sketch that on if I can. So I'm going to draw the asymptote. Okay, oh, it's not so good. And so then the curve is going to kind of come through here like that. Oh yeah, something like that. And it's going to go down like that to that asymptote. And that's the graph of f. So now if I want to do the inverse of that, essentially, it's just going to be a reflection in the line y is equal to x. So if I was to draw the line y is equal to x, like this, something like that, then we're going to have a reflection. So the asymptote is going to get reflected. So we're going to have the line x is equal to 3 instead of y is equal to 3. And we're going to go through x is equal to 5 instead of y is equal to 5. And so that's going to look something like this. Oh, let me just try to do that a bit better. And notice that I've drawn it so that it intersects at the line y equals x as well. Okay, so we just need to label that as f inverse. And I need to make sure that I label that as x is 3 and x is 5. And that should be all of our marks. Okay, then question B. The function g is defined by 2 minus 3 upon e to the x plus 2 for a domain of x is greater than 0. And given that g inverse does exist, find an expression for g inverse and state its domain. Well, okay, I think in order to do this right, we really need to think about what an inverse function is. So I'm going to go through that theory again. So let's say that we've got a function f, right? How does that usually work? Well, we have an input, which we typically call x, and we get an output, which we typically call y. Well, what's the job of the inverse function? The inverse function is supposed to take us from our outputs and give us back our original inputs. Okay, so in other words, it's supposed to undo the action of the original function. So, for example, if we had an input to the function f and that input was 3, and we get as an output the number 10, then what should the inverse function do? It should take that output 10 and bring me back to my original input, which was 3, right? So in other words, it undoes the action of the original function. Now, this helps us to understand questions of domain and range, right? So, for example, what's the domain? The domain is the set of all of the input values. So let's say the domain for the original function is x is greater than or equal to 2. Okay, so that's the domain of f. And what's the range? The range is the set of all the possible output values. So let's say in this case, the range of the output values is all the numbers greater than, I don't know, -5. Right, so that would be the range of f. Well, if we think about it right, what are all the possible inputs to the inverse function? Well, they must be all of the outputs of the original function, right? So every single possible output from the original function needs to become an input to the inverse function. So if we understand this, then we also understand that the domain of the inverse function must be the same thing as the range of the original function, right? So if all these outputs is everything greater than -5, then the inputs to the inverse function must also be everything that's greater than -5. And in the same way, what would the outputs of the inverse function be? Well, it would have to give us all of the inputs to the original function. In other words, it would have to be every value that's greater than or equal to 2. Okay, so if we understand this right, the core idea is that the domain of the inverse function is the same as the range of the original function, and vice versa. The range of the inverse function is the same as the domain of the original function. So when we are asked in this question to find an expression for the inverse and state its domain, right, the domain of the inverse function is going to be the same thing as the range of the original function. So we want to find the range of this guy. Okay, so let's go down. Let's now consider the question in full. So g of x is equal to, what is it equal to? It's equal to 2 minus 3 over e to the x plus 2. Okay, now you don't need to know how to sketch this graph, but you need to roughly have an idea of what it is going to look like. So x is greater than 0. Yeah, greater than 0. Yeah. Well, what's going to happen when x is 0, right? When x is equal to 0, then g of 0 is going to be 2 minus 3 over e to the power of 0 plus 2. Well, what's e to the power of 0? It's 1. So we've got 2 minus 3 divided by 1 plus 2, which is 3. So 2 minus 1 is 1. Right, so when x is 0, the y value is going to be 1. What about when x tends to infinity? As x gets really big? Well, as that happens, right, e to the x is going to get really, really big, which also means that e to the x plus 2 is going to get really big. And so 3 over e to the x plus 2 is going to get really small. It's going to become almost 0. So what we're going to be left with is g is going to be 2 minus a really, really small number. Right? So in other words, g is going to tend towards 2. So we've got a range of g, which is going to follow the following, right? It's going to be between 1, right, greater than or equal to 1, but also less than 2. And therefore, we actually know the domain of the inverse function, because it's going to be the same thing, right? It's going to be the x must be between 1 and 2. Okay, so we've got the conditions for the domain now, because we know it's the same thing as the range. Okay, so then how do we actually find the inverse function? Well, if y is equal to 2 minus, what was it, 3 over e to the x plus 2, basically, what are we trying to do? The inverse function, right? We're trying to get our inputs in terms of our outputs, right? We're trying to reverse the operation. So we're just rearranging this guy to make x the subject. So how can we do that? Well, I could add this to both sides and I'll subtract y from both sides. So I'm going to get 3 over e to the x plus 2 is equal to 2 minus y. I will flip the fraction. E to the x plus 2 over 3 is equal to 1 over 2 minus y. Just rearrange that. So therefore, e to the x plus 2 is equal to 3 over 2 minus y. So e to the x is equal to 3 over 2 minus y minus 2. And therefore, x is equal to the natural log of 3 over 2 minus y minus 2. And then the last step is just to write this in the notation where x is the input. So basically we replace the y's with x's and we get the natural log of 3 over 2 minus x minus 2. And I'm just going to check with the mark scheme, see if that's the way they're happy with it. Yep, that's absolutely fine. So you can have that answer or any other equivalent. That's all okay. All right, I hope that's helpful. Okay, then here we are in question 8. Solve the equation 2 minus 3 cot x times by cos x is equal to 0 for a domain of x is between 0 and pi by 2. Well, firstly, we've got two things that are multiplied together that equal 0. So that means either this thing here is equal to 0 or this thing here is equal to 0. So we're trying to solve two things. Either 2 minus 3 cot x is equal to 0, or we're trying to solve cos x is equal to 0. Okay, so we just leave the one on the right just for a second. We're going to rearrange this guy here. So we are going to get 3 cot x is equal to 2, and therefore cot x is equal to 2/3. And what is the definition of cot? Well, we always look at the third letter. So 1, 2, 3, we get t. So cot is 1 divided by tan. So we can simply write this as tan x is equal to 3 upon 2, right? So I take the reciprocal of the right-hand side there. So we're trying to solve this. So tan x is 3 upon 2, and cos x is equal to 0 for values between 0 and pi by 2. Now then, I think in order to understand what's going on here, it's best to think again, what do sine, cos, and tan actually mean? So we're going to review that very quickly. And the best way to do that is to think about the unit circle, right? So we've got a unit circle here, by which I mean a circle of radius 1. Okay, so there we go, circle of radius 1, like that. And I want you to imagine that on this circle of radius 1, we've got a point. And the point there has got an x-coordinate and a y-coordinate. And that point makes an angle of theta with the positive x-axis, right? So this angle there, that's theta. And basically what happens, right, is if I take that point and I drag it all the way around the circle, right, then as the angle of theta changes, then the x and the y coordinates also change, right? So if I imagine that I'm here where the angle is 0, the x-coordinate will be 1 and the y-coordinate will be 0, right? Whereas if I move the angle around to here, so I've got 90 degrees, the x-coordinate will be 0 and the y-coordinate will be 1. So essentially what we can say is that the x and the y coordinates are both functions of the angle, and those functions are what we call sine and cos. So the x-coordinate is given by the cosine of an angle, and the y-coordinate is given by the sine of the angle. Right, and that should kind of make sense, because if we just think for 1 second, right, what does it mean when we say cos 180? Well, it means when the angle is 180 degrees, so we're here, what is our x-coordinate? Well, our x-coordinate's -1 there, right, and cos 180 is -1. Okay, so we've got that. So let's imagine this guy. We're trying to solve cos x is equal to 0. So what we're really trying to do is we're trying to find where the x coordinate is equal to 0, right? Because cos tells us the x coordinate. So we want to find on this circle where is the x coordinate 0. Well, there are two places, right? We've got a place that's here, and we've got a place that's here, right? Because in both of these locations, the x coordinate is 0. So what angle brings us to this point? Well, the angle is 90 degrees or pi by 2. And what angle brings us to this point? Well, that would be 3 pi by 2. And that's outside of our domain, right? So we've only got one solution for that, which is the angle is pi by 2. Okay? All right, then. Well, what about this guy here? Tan is equal to 3 upon 2. Well, we've done sine and cos, right? So what does tan refer to? Well, tan refers to the gradient from the origin to our point, right? So tan theta represents the gradient of this line here. Okay, so what we want to do is we want to find the angle such that the gradient is 3 upon 2. Okay, and so if we were to do that, right, we can imagine that what we're going to end up with is we're going to end up with a line like this. The gradient of that line will be 3 upon 2. So we're going to end up with two locations, right? We're going to end up with a location here, and we're going to end up with another location, which is there. And of course, we're only interested in this one because we just want angles between 0 and pi by 2, right? So this guy, I'm not interested in. So we can plug that into our calculator. And if we do that, we'll get a value of x. And remember, we're dealing with radians. You want to say you calculate a radians mode. And I get that is 0.983. And remember, you need to give the answers to 3 significant figures or 1 decimal place, I think. Let's just read the instructions. Yeah, non-exact numerical answers correct to see 3 significant figures or 1 decimal place for angles in degrees, right? So in this case, we want to use 3 sig fig. As we end up with 0.983 as one and pi by 2 for the other. Okay, then part B of the trigonometry question, we want to solve this equation here, where theta is in radians between -1 and +2. Okay, well, my solution's it's going to take quite long because I like to be very meticulous when we're doing this kind of questions, but I hope at least it will be clear and you can follow it through on your own questions. So what's my first step? Well, firstly, I recognize that the 2 theta plus 1, right, makes this a little bit more complicated. So straight away, what I do is I do a substitution. I say let u equal 2 theta plus 1. Okay? And incidentally, what that also means is that I can write theta as being equal to u minus 1 over 2, right? So just rearrange it. So I can then take the equation 2 cosec 2 theta plus 1 and so on and rewrite it as 2 cosec u minus 12 sine u is equal to 5. Okay? All right, then what's my next step? Well, I can look at this cosec, right? So what is cosec? I look at the third letter. Third letter is s. So this is 1 divided by sine. So I've got 2 times by 1 over sine u minus 12 sine u is equal to 5. And hopefully at this point you've done enough papers that you can recognize that this is going to be a hidden quadratic, because if I take the entire equation and I multiply it by sine u, then this term will become 2. This will become minus 12 sine u squared, or sine squared u, and this will be 5 sine u. Okay, so if I now rearrange all of this, and instead of sine, I'll just write s, okay? I'm going to get 0 is equal to 12 s squared plus 5s minus 2. And that's a quadratic, and hopefully we can solve that quadratic. We can attempt to factorize it. And if we can't factorize it, then of course we can use the quadratic formula. Now I'm going to try to do it anyway. So I've got 12 sine squared here, so that's a little bit tricky because it could be like 12 sine times 1 sine, or 6 sine times 2 sine, or 3 sine times 4 sine, or whatever. But this guy here is fairly straightforward, right? -2, I'm looking for two numbers that multiply together to give -2. So it's either going to be +2, -1, or the other way around, -2 and +1. Well, I did this earlier, I must confess, and so I was able to kind of fiddle around with the numbers and get that 3 sine plus 2 times 4 sine minus 1 makes everything work there, right? So we can just double check that, right? 3 sine times 4 sine is 12 sine squared. 3 sine times -1 is minus 3 sine plus 6 sine. Okay, so the minus 3 sine plus the 6 sine. 1 second. Sorry, I was going a little bit mad there. It's the minus 3 sine plus 8 sine, isn't it, right? Which does equal to 5 sine. And we get 2 times -1, which is -2, right? So that quadratic does work. Okay, so we've got two solutions. We've either got that sine u is equal to -2/3, or alternatively, we've got that sine u is equal to 1/4, right? So now what we've got to do is we've got to solve these two equations here. Okay. All right then. How do we do this? Well, in part A, right, I illustrated to you the unit circle, right? So I'll just quickly go back to that, right? Actually, I'll just do it quickly again. So sine and cos, right, they come from this idea of the unit circle. So the unit circle is the circle with radius of 1. So there we go. Here's a circle of radius 1. And basically what we say is we imagine that we've got a point that's on that circle. So we've got a point, let's say, here. And that point has got an x-coordinate and a y-coordinate. And it makes an angle of theta with the x-axis. And what we want to imagine doing is taking that point and dragging it all the way around the circle. And as I drag the point around the circle, then the x-coordinate and the y-coordinate change. And so that means that the x and the y coordinates are both functions of the angle. And the x coordinate is a function that we call cosine, and the y coordinate is a function that we call sine. So in other words, what is sine and cosine? They tell you the x and the y coordinates on the unit circle. So for example, if we say sine 90, what it means is what is the y coordinate on the unit circle when the angle is 90, right? So the angle is 90, brings us up to that point. So what's the y coordinate of that point? The y coordinate is 1. So sine 90 is 1. In the same way, what is cos 270? Well, 270 brings us around to that point there. We want the cos of it, so we're asking what's the x coordinate, and the x coordinate is 0, right? So cos 270 is 0. So in this particular question, right, when we've got, for example, sine u is equal to -2/3, what we're really asking is, what is the angle u where the y coordinate on the unit circle is -2/3? Right, let me repeat that. This thing means, what is the angle u where the y coordinate on the unit circle is -2/3? So that's what we're going to do. So I'll just get rid of this, tidy it up a tiny bit, yeah, like that. Where is the y coordinate equal to -2/3? Well, we could draw it out. Let's say it's somewhere here, right? So what we're interested in is we're interested in this point here, and we're interested in that point there, right? I'll call them points A and B, respectively. Okay, and if we were to do sine inverse of -2/3 in our calculator, beg your pardon, then what we would get is we would get one particular value. So I think if I do that, I get -0.730. Right, so that angle there, right, that angle there would be -0.730. And we got to think, right, how would I get this angle here, right? So I'll draw that on in yellow, this angle here that takes me to the point B. Well, let's just think. The reason this is negative, right, because it means we're going clockwise, right? So the actual size of the angle is 0.730, right? That's the size of the angle. But negative means we're going that way. This angle here has to be the same size as that angle, right? So if that's 0.730, that angle there is 0.730. So this angle, the one in yellow, would have to be pi radians, because that takes me up to there, minus the 0.730, right? So the size of the yellow will be pi radians minus the 0.730. And of course, because we're going anti-clockwise, again, it would have to be negative. So we end up with two answers. We would get negative 0.730, and I just need to use my calculator just for a second. Okay, so I would get that to give me minus 2.411, I think. Okay. All right, so that would be the kind of the two basic angles, right? So that one there and that one there. And the thing is, we also need to recognize that, let's imagine I've got this point and I go round the circle. So in other words, I go round an angle of 2 pi, I get back onto the same point. Okay, and the same thing with B, if I take that point and I go round by 2 pi, I get back on to the same point. So I can take both of these answers here, right? And I can add or subtract multiples of 2 pi to them. Okay, and I would still get a valid solution. Okay, well, what about this guy here, right? We've got sine u is equal to a quarter. So what does that mean? Well, we want to find the angle u where the y coordinate on the unit circle is a quarter, right? So we want to find the angle u where the y coordinate is a quarter. If we do that, then let's draw out where y is equal to a quarter. Let's imagine it's there. So this is y is equal to a quarter. And we could either be at this point or we could be at this point. So we call that C and call it D. So we can have that angle, or we can have that angle. And the angle that takes us to C, right, we can just find by doing sine inverse of a quarter. And so if we do sine inverse of a quarter, I think what we'll get is 0.253. So we also get u could be equal to 0.253. And what about this other angle? So I'll draw this angle now in yellow. So that angle there. Well, we use a similar argument, right? If this is 0.253, that angle there is 0.253. So the one in yellow has to be pi radians minus that. And if we did that, then what we should get is 2.889. Okay, so we end up with these kind of 4 basic solutions, but also we could take them and add multiples of 2 pi and still get valid solutions, right? So if I'm at C, if I add 2 pi, I get another valid solution. If I'm at D and I add 2 pi, I get another valid solution. Now then, which of these are we actually interested in? Because we're given a domain, right? The domain is that theta needs to be between -1 and +2, right? So we don't know which one of these guys is going to fit. Well, what we could do, right, is we could take our substitution, right? U is equal to 2 theta plus 1. And we could take our values of u, substitute them into here, get the values of theta, and see if those values of theta fit within inside that substitution. We could definitely do that, right? So just take every value of u that we got, substitute it into here, get the value of theta, see if it fits. But I think it's probably better to just put an intermediate step in so that we know which values of u immediately we should accept or reject. Okay, now what I mean by that is this. We know that theta is u minus 1 upon 2. So what we're going to do is we're going to take that thing, we're going to substitute it into this inequality here, right? So I'm going to write down that instead of theta being between -1 and 2, we've got u minus 1 upon 2 is between -1 and 2. So therefore, if we multiply everything through by 2, then we've got that u minus 1 must be between -2 and +4. And if we add 1 to everything, we know that u must be between -1 and +5, right? So we are interested in these values of u that are between -1 and +5. So what does that mean? Well, it means that one is okay. That's fine. But this guy is not fine because it's outside the bounds for u. So what could we actually do? Well, we could take this guy and we can add 2 pi to it and see if we get a valid solution, right? So if I take the -2.411 and what I do is I add 2 pi, then what I get is 3.87, right? And 3.87 does fit within that set of values, so that's good. What about this guy over here? 0.253. Yeah, that fits within these values. And what about this guy here? 2.889. Yeah, that fits within these values. And I should probably just do like one final check, is that I should add and subtract 2 pi to all of these and see if I get another value that fits inside. But I don't think I do, right? So my values for u, which are acceptable, are now this, 3.87, this, and this. Okay, so then the final step is just to find the values of theta, right? And we said that theta is equal to u minus 1 upon 2. So therefore, we just take each of these values for u that we know are acceptable, those four, and we subtract 1 from them, and we divide by 2 to convert them to theta. And if I do that, what I get is that theta will be equal to negative 0.865. I will get 1.435. I will get negative 0.374. And I will get 0.945. Right, actually, I think probably this guy here needs to be to 3 significant figures, doesn't it? So it's probably I should write it as 1.44. Okay, but those should be my final answers. And I'm just going to quickly check the mark scheme, make sure that I did get that right. So where is it? Yeah, that one's right. That one's right. And yeah, they have it as 1.44. So do beg your pardon. Let me just change that. 1.44. Needs to be to 3 significant figures. Okay, now I think you're probably looking at my answer and going, well, that took a lot of time, and isn't that quite a lot of unnecessary steps? Well, yeah, maybe. But I find with a lot of students, when they do this, they're basically guessing steps. And I think what you want to do is you want to minimize the stuff that you're guessing and try to maximize the stuff that you actually know, right? So you can logically explain each step. So each step that I've taken, right, using a substitution, knowing exactly what this thing means on the unit circle, being able to deduce what the angles are by using the properties of reflection and geometry, by knowing that I can add 2 pi and the reason why, right? Each one of these things, right, they take time to understand and to learn, but the core thing is then you actually really properly understand what's going on. And the more you understand what's going on, the more confident you're going to be with doing these questions and with getting all of the right answers, right? So if you find that what's happening is you're getting like whatever 4 marks out of 6, but you're losing the last 2 because you're guessing, then what you need to do is you need to rethink how you approach it and try to be more meticulous in your understanding, right? So if you do these steps, I know it takes a bit longer, but I think it's going to really, really help you to ensure that in the end, you actually get the right answer. Okay, question 9. The diagram shows a sector AOB of a circle, which is this guy here, with the center of O, a radius of 15, and an angle of 6 pi upon 5. The sector is made into a cone, which is over here with the points A and B touching. In other words, we fold this guy round, right, so that this point here then touches this point here, and we end up with that cone. Find the curved surface area of the cone. Well, then the curved surface area is the same as the area of the sector. And what's the formula for the area of a sector? The area is equal to a half r squared theta, where theta is the angle in radians. So we just substitute in a half times by the radius, which is 15 squared, times by the angle, which is 6 pi upon 5. And let's say we don't have a calculator. We can do a half times by 15 times by 15 times by 6 pi over 5. Well, we can cancel off, can't we? So we divide top and bottom by 5, so that guy becomes 3. And we can divide by 2, so that 6 becomes 3. So if we were to simplify this, we end up with 15 times by 3 times by 3 pi. Okay, so then what's 15 times by 3? It's 45. 45 times by 3, well, 40 times 3 is 120. 5 times 3 is 15. So add them up, you get 135 pi. Okay, and in this question, they don't ask you for the exact value, so you may have to put it into a calculator and find the like the decimal equivalent. So I don't have a calculator on me, so I'm just going to check the mark scheme. So that would be 424 to 3 significant figures, right? So it's also the same thing as 424 centimeters squared to 3 significant figures. Okay, then part B. The top of the cone is a horizontal circle. Find the circumference of the circular top. Well, let's just have a look at the diagram, right? So this circular top is what we're being asked to find. Well, that length there is the same as that length there, and that length is the arc of a circle. How do we find the arc of a circle? S is equal to r theta. We just used that formula. So r is 15, and the angle is 6 pi upon 5. So if we were to simplify that, divide top and bottom by 5, that becomes 3. So we get 3 times 6 pi is 18 pi. And again, I don't know what the exact value is of that, but if we times it by pi, we get 56.5. Okay, so we could also say 56.5 centimeters to 3 significant figures. Okay, so hence find the radius of the circular top and the perpendicular height of the cone. Well, we just need to think what we're being asked here, right? So the radius of the circular top is that's what they mean. And the height is this thing here. So I'll call the radius capital R, I guess, and I'll call the height capital H. And so what do we know? Well, we already know this length here, right? We know the circumference of the circle because that was 18 pi. That's the answer we just got. And the circumference of a circle is equal to 2 pi r. So I can just write out circumference of a circle is 2 pi times by r. I know that the circumference is 18 pi. So 18 pi is equal to 2 pi r. I divide both sides by 2 pi. So r is equal to 9 centimeters. And then lastly, how can I find h? Well, I've got a right angled triangle here. So h squared plus r squared is equal to 15 squared. So I'm going to write that down. H squared plus r squared is equal to r is equal to 15 squared. So h squared plus r, which is 9, so 9 squared is 81, is equal to 225. So h squared is 225 minus 81, which I think is 144. Yeah, 144. And therefore h is equal to 12. Okay, so we get 12 centimeters there. All right then, part D, water is poured into the cone. When the depth of the water in the cone is h, the radius of the circular top of the water is r. Find an expression for r in terms of h. All right, okay, so I think just, again, having a clear diagram here helps. So here's my cone, right? So there's the cone. And inside this cone now, what we've got is we've got some water. So let's say the water kind of goes up to there. Oh, beg your pardon. Like that, like that. And what are we doing? Well, we are defining this length here, like that length there, as being small h. And we're defining this length here as being small r. But if we think about it, right, what we've got is we've got a similar triangle with what we had before, right? This kind of big thing. Ooh, beg your pardon. Like that. Right, where this length here was what I called big R, and this height here is what I called big H. Right, so in other words, we know that the ratio of big R to big H must be the same thing as the ratio of small r to small h, right? Because these are similar triangles, okay? And so big R was what? Big R was 9 and big H was 12, right? So 9 upon 12 must be equal to small r upon small h. And so therefore, rearranging, r is going to be equal to 3/4 of h. Okay, so it's just using similar triangles, and I think a clear diagram makes that clear. Right then, part 2 of this question, the water is poured into the cone at a constant rate of 27 centimeters cubed per second, beg your pardon, and find the rate at which the depth of the water is rising when the depth of the water is 4. Okay, so what does this mean? The water is poured into the cone at a constant rate of 27 centimeters cubed per second. So this is the volume per second, or the rate of change of the volume per second. So we can write that and say that is actually dv dt, right? So dv dt is the rate of change of the volume with respect to time, and that's equal to 27. What we're asked to find is the rate at which the depth of the water is rising, so the rate at which this h is changing with respect to time. And how could we write that? Well, that is dh dt. So we want to find dh dt. Okay, well, what's the relationship between dv dt and dh dt? Well, this is a chain rule. We can say that dv dt is equal to dv dh times by dh dt, right? And the way we can think about that is we can imagine the right-hand side, these guys are fractions, right? They're not really fractions, but we can imagine that. And the dh's will cancel off and we're left with dv dt. Okay, so what have we got? We know dv dt, that's 27. We want to find dh dt, so that's the thing we want to find. So dv dh is the only thing that we're left with. So we want to find dv dh. Well, how can we do that? Well, we need an expression for the volume. Now, the volume of a cone, according to the front page of your exam, right, the formula sheet, is a third AH, where the A is the surface area of the circular face. And so the area of the circular face is pi r squared, right? And we've just learnt that the radius is equal to 3/4 of h, right? So that's what we did in the previous part. So this is 3h upon 4 squared times by h. And of course, if we expand that, we get a third times pi times by 9h squared upon 16 times by h. And this should simplify, right? Because 9 divided by 3 is 3. So we get 3 pi h cubed upon 16. Well, then if we differentiate this, so if we differentiate the volume with respect to h, so dv dh, then what we'll get is we'll get 9 pi h squared upon 16. Well, if we just remember then that we said we were trying to find dv dt is equal to dv dh times by dh dt. Well, now we can just substitute everything in. Our dv dt we know is 27 because we've told it in the question. Our dv dh is 9 pi h squared upon 16, and dh dt is the thing we're trying to find. And we're told we want to do this when the height is equal to 4, right? So we just substitute in, so this is 27 is equal to 9 pi 4 squared upon 16 times by dh dt. And obviously 4 squared is 16, right? So that cancels off with that. And so therefore, dh dt is equal to 27 divided by 9 pi. And I think we can divide that through by 9, can't we? Which I think would be 3 divided by pi. So pi is ever so slightly bigger than 3. So it should be a number that's a little bit less than 1. So if I just check the mark scheme, the value is 0.955. Yeah, that's basically going to be right, isn't it? So 0.955 to 3 significant figures. And of course, the units will be centimeters per second, right? Because it's rate of change of height with respect to time. Okay, so I hope that's clear. I think that's a slightly challenging question. But I think so long as you've got good, clear diagrams, actually should be okay. Okay, question 10, which is a kinematics question. A particle P moves in a straight line. T seconds after passing a fixed point O. The acceleration of P, which is A, is given by this piecewise function. So it's equal to T squared minus 2 when T is between 0 and 4. And it's equal to 19 minus 5 e to the power of 8 minus 2t between t is 4 and 10. And we're told that when t is 3, beg pardon, the velocity of p is negative a third and its displacement from O is negative a quarter. Find the velocity of p when t is equal to 4. Okay, so in order to understand this right, we basically got to understand the relationship between displacement, which we call s, and velocity, which we call v, and acceleration, which we call a. And basically, it's that velocity is the rate of change of displacement with respect to time, so it's ds dt. And acceleration is the rate of change of velocity with respect to time, so it's dv dt. And so therefore, if I want to go from displacement to velocity and from velocity to acceleration, what I do is I differentiate. And consequently, if I want to go from acceleration up to velocity or from velocity up to displacement, I need to integrate. Why? Because integration is the reverse of differentiation. So I'm starting with acceleration, right? And what I want to do is I want to find velocity. So I've got to integrate. So velocity is equal to the integral of the acceleration with respect to time. In other words, I'm going from here up to here. And we want to find this for the first part, right? For when a is between 0 and 4. So we are going to integrate t squared minus 2. And if we integrate that, then we get t cubed upon 3 minus 2t plus some constant. And we're told in the question that when t is equal to 3, the velocity is negative a third. So we can substitute in when t is equal to, what was it, 3, v is equal to negative a third. So if we substitute in negative a third is equal to 3 cubed over 3 minus 2 times by 3 plus c. And 3 cubed divided by 3, right, is just 3 squared. So what we end up with here is negative a third is equal to 3 squared, which is 9, minus 2 times 3, so it's minus 6 plus c. And so therefore, 9 minus 6 is 3. So c is equal to negative a third minus 3. And 3 is the same thing as 9 thirds, right? So we've got minus third minus 9 thirds, that's minus 10 upon 3. So our velocity is equal to a third t cubed minus 2t minus 10 upon 3. That's our c value. And we're asked to find the velocity when t is equal to 4. So when t is equal to 4, right, the velocity is equal to a third of 4 cubed minus 2 times by 4 minus 10 upon 3. Okay, well, 4 cubed is 64, so we've got 64 upon 3. 2 times by 4 is 8. Well, I'm going to change that to be 24 upon 3 minus 10 upon 3. So 64 minus 24 is 40, minus 10 is 30. So we get 30 upon 3, which is equal to 10. Okay, so that's 10 meters per second is the velocity when t is equal to 4. So then what we want to do is we want to find the displacement, right? The displacement of p from O when t is equal to 4. So again, how do we go from velocity to displacement? Well, we've got to integrate, right? Because we're looking at this guy here, right? We're going from velocity up to displacement. And so my formula for velocity, we've just said, is a third t cubed minus 2t minus 10 upon 3 dt. So if I integrate that, I get 1 upon 12 t to the 4, right? Add 1 to the power, which is 4 divided by the new power, minus t squared, and minus 10 upon 3t, plus some other constant, I'll call the constant k. Okay, and we're told that when t is 3, the displacement is negative a quarter, right? So I can substitute in. So when t is equal to 3, s is equal to negative a quarter, right? So if I do that, negative a quarter is equal to 1 upon 12 times by 3 to the power of 4 minus 3 squared minus 10 upon 3 times by 3 plus k. So let's try to simplify it. So that 3 cancels with that. And we can divide top and bottom by 1, 3. So that'd be 3 cubed, and that would be 4. So we get negative 1 upon 4 is equal to 3 cubed, which is 27 upon 4, minus 9 minus 10 plus k. So k will be equal to what? Will it be minus 1 upon 4 minus 27 upon 4 plus 9 plus 10, I think? And so we're going to get negative 28 upon 4 plus 19, I think. And negative 28 upon 4 is negative 7, isn't it? So negative 7 plus 19. So that's going to be equal to 12. So our constant is 12. So if we just go back over here, right, what's our velocity? Not what's our velocity? Our displacement is 1 upon 12 t to the power of 4 minus t squared minus 10 upon 3t plus k, where k is now 12. And so we want to find this when t is 4, right? So when t is 4, we are going to get s is equal to 1 upon 12 times by 4 to the power of 4 minus 4 squared minus 10 upon 3 times by 4 plus 12. And divide top and bottom by 4, so that becomes 4 cubed, and that becomes 3. And I think it's probably about as simple as I can go. So 4 cubed is 64 upon 3 minus 16 minus 40 upon 3 plus 12. So again, let's change all of that to thirds, I think. So 64 upon 3 minus 48 upon 3 minus 40 upon 3 plus 48 upon, no, not 48, 36 upon 3, beg your pardon. Oh, well, what's that going to be equal to? Add 64 plus 36, 100 upon 3. So 100 upon 3 minus 88 upon 3, which I think is 12 upon 3, and that guy is equal to 4. Okay, so the displacement there should be 4 meters. Okay, so that's that. All right, then, part B of this question, we want to find the displacement of P from O when T is equal to 10. Well, that means that we are now considering the situation where we're in this part, right? So in part A, we just considered the first kind of domain for the acceleration, which is between 0 and 4. Now we've got to consider the second part. And again, if we want to find displacement, we're going to need to integrate this acceleration once to get velocity, and we're going to need to integrate it again to get displacement, right? So we are saying that velocity will be equal to the integral of the acceleration with respect to time, and that acceleration is equal to 19 minus 5 e to the power of 8 minus 2t dt. Let me just double check that again. Yeah, that's right. So I've got to integrate that. So if I integrate 19, I get 19t. If I integrate the exponential, I get the exponential. So e to the 8 minus 2t. I've got to divide through by the coefficient of the t, which is negative 2. And I've got to add a constant. And I better use a different letter, right? Oh, I don't know what letter to use. Let's use lambda, okay? Because we've used c and we've used k. And what do we know? What's kind of the boundary condition for this? Well, we know that when t is equal to 4, right? In other words, when we cross over from being in this situation to being in this situation, we know that when t is equal to 4, the velocity is equal to 10. Okay, so the velocity must be consistent, right, as we cross over. So when t is equal to 4, v is equal to 10. So we can now apply this and say 10 is equal to 19 times by 4 plus 5 upon 2 e to the power of 8 minus 8 plus lambda. And so we've got 10 is equal to 19 times by 4, which is 76, plus 5 upon 2 times by 1, because e to the power of 0 is 1, plus lambda. So the lambda is going to equal to 10 minus 76 minus 5.2. So 10 minus 76 is minus 66, and then minus 5.2, which is minus 2.5, which is minus 68.5. And I think, actually, to be honest, I prefer things as decimals. So that's minus 137 upon 2. Let me just double check that. 120, 100, yeah, 137 upon 2. Okay, so therefore, I'm going to write, so therefore, velocity is equal to 19t plus 5 upon 2 e to the power of 8 minus 2t minus 137 upon 2. And so then I want to find displacement from that, right? And displacement is equal to the integral of velocity. So I've got to integrate this whole thing. Right? So I'm just going to write it out again. E to the 8 minus 2t minus 137 upon 2 dt. Okay, now if I integrate it, 19t squared upon 2 plus 5 upon 2 e to the power 8 minus 2t, but I've got to divide through by negative 2, minus 137 upon 2t, and then I've got to add another constant, which is going to be mu. And again, using the similar argument, right, is we know that at the point where we cross over, right, from this domain, from 0 to 4, to this domain, the displacement must be the same. So that we know that when t is equal to 4, from the previous question, the displacement is also equal to 4, right? So we can write down when t is 4, displacement s is equal to 4, because we already calculated that. So now we can just substitute this in. We have got 4 is equal to 19 upon 2 times by 4 squared plus, or minus rather, minus 5 upon 4 e to the power 0 minus 137 upon 2 times by 4 plus mu. So let's try to simplify all this. So we got 4 is equal to 19. 4 squared is 16, divided by 2 is 8. E to the power 0 is 1, so that's minus 5.4. Minus, I don't know, 137 times by 4 divided by 2. So it's 137 times by 2, which is 274, I think. Yeah, 260 plus 14, plus mu. Okay, so let's try to simplify that. So that's 4 is equal to 76. Yeah. No. 20 times by 8 is 160. Minus 8 is 152, isn't it? Yeah. Minus 5.4, minus 274 plus mu. Okay, so let's try to get this all right. So mu is going to be equal to 4 plus 274 plus 5 upon 4 minus 152. All right, okay, so that plus that is 278. So we got 278 minus 152 plus 152 plus 5.4, which is what? That is 126, I think. 126, yep. Plus 5.4. Okay, well, let's again do it as a fraction, I think. So double it is going to be 252. So 252 upon 2 plus 5.4. Double it again is what? 504. 504 upon 4 plus 5 upon 4, which I think is 509 upon 4. All right, 509 upon 4. And so we can now write and say S is equal to, this horribly long thing. What is it equal to again? 19 upon 2 t squared minus 5 upon 4 e to the power 8 minus 2t minus 137 upon 2t plus the 509 upon 4. And we want to find the displacement. What was it? When t is 10. Okay. So when t is equal to 10, s is equal to 19 upon 2 times by 100 minus 5 upon 4 e to the 8 minus 20 minus 137 upon 2 times by 10 plus 509 upon 4. Okay, well, frankly, guys, I've kind of, I don't have a calculator, and there's no way that I can actually do that in my head, so I give up with that. So let's just check the mark scheme, and I'm sorry to chicken out. 392. Okay, so the 300 significant figures, this is 392 meters if you substitute everything in. Okay, guys, I hope that was helpful. Right then, question 11 here. So a geometric progression has first term a and a common ratio r, where r is positive. The sum of the second and the third terms of the progression is 168, and the sum of the fourth and the fifth terms of the progression is 94.5. Find the sixth term of the progression. Okay, so a good thing to know, right, for a geometric progression is the nth term is a times by r to the power of n minus 1, where a is the first term and r is the common ratio. So the sum of the second and the third terms, right? So the second term is going to be a times by r, and the third term is going to be a times by r squared, and that's equal to 168. Okay, so if we imagine, right, this is like statement 1, and so that equation here comes from that. Okay, and statement 2, the sum of the fourth and the fifth terms is 94.5. Well, the fourth term is going to be ar to the power of 3, and the fifth term is going to be ar to the power of 4. So that's going to be equal to 94.5. So what have we got here? We have got two equations, and we've got two unknowns. So this is simultaneous equations. So we want to try to be as clever as we can about this, because otherwise the algebra is going to be very long and very complicated. So what I suggest you do is you factorize out ar from both expressions. Right, so we've got ar bracket 1 plus r is equal to 168. And then from the second equation, if we factorize out ar, let's factorize out ar cubed, I think. Then we'll get 1 plus r there. Okay, now the reason I've done that, right, is because now, if you look at both these equations, what common factors have I got? Well, I've got common factor of 1 plus r, right, and I've got a common factor of a. So what does this mean? It means that if I divide equation 2 by equation 1, then something interesting is going to happen, right? Which is this term is going to cancel off with that term, and that a is going to cancel off with that, and we're just going to be left with r cubed divided by r. So if you're really not sure what I've just said, let me write it out in full. ar cubed bracket 1 plus r equals 94.5. And then we're going to divide that by the first equation, which is ar bracket 1 plus r is equal to 168. So now things are going to cancel off very nicely, right? 1 plus r cancels off, the a cancels off, r cubed divided by r is r squared, so r squared is equal to 94.5 divided by 168. Well, okay, let's assume that we don't have calculators, okay? I always think that's a good assumption to have. So I'm going to multiply top and bottom by 2. So that would be 189, right? Because 90 doubled is 180, 4.5 doubled is 9. And if I double 168, well, 160 doubled is 320, plus 16 is 336. Okay. Okay, so I think I can try to factorize this, I guess. So both of these look like they're multiples of 3, right? I can check by adding up the digits. 1 plus 8 plus 9 is a multiple of 3, and this is a multiple of 3. So I'm going to try to factorize out 3. So that would be 63 here, right? Because 180 divided by 3 is 60, and 9 divided by 3 is 3. And I'll factorize out 3 here, which will give me 112. So I can divide top and bottom by 3. And again, I think 63 and 112 can also factorize out by 3. So it's 3 times by 21 over, oh, I don't know, 3 times by 30, let's see, 90, 3 times by 30 would be 90, right? And then that gives me another 22. Oh, no, it doesn't, that doesn't factorize by 3, does it? Okay, so maybe I've gone wrong there. Let's try another thing. Let's just try to simplify it. That's 3 times by 21. 112, okay, I can write that as 2 times by 56. Okay, and then 21 is 3 times by 7. And 56 is 7 times 8, so 7 times by 8. Okay, well, the 7 cancels off, gone gone. So then what I end up with is 3 times 3 is 9 upon 2 times 8, which is 16. Ah, okay, brilliant. So r squared is 9 upon 16. So r is equal to plus or minus 3/4, but we're told that we just take the positive, so it's equal to 3/4. Okay. All right then. And so what can I do? Well, I want to find out what the value of a is. Oh, so I don't know. So I'll substitute it into this first equation. So a times by r, which is 3/4, times by 1 plus r. So it's 1 plus 3/4 is equal to 168. So a times by 3/4 times by, what's that, 7 upon 4 is equal to 168. And so a is equal to 168 times by 4 times by 4 divided by 3 divided by 7. And yeah, is there any simple way of solving that? Maybe. We said 168 was divisible by 3, wasn't it, right? That's 3 times by, what was it, 56? Yeah, times by 4 over 3 times by 7. So that goes gone, gone. 56 divides by 7, because it's 7 times 8. So we end up with 8 times by 4 times by 4. So 8 times by 4 is 32, and then 32 times by 4, 64, 128. Okay. Now, guys, I know it's probably quite boring. You sat there thinking, you know, why don't you just use a calculator, right? We're allowed a calculator. This is paper 2. I'm just trying to demonstrate for you that you can actually do things without a calculator. And sometimes, you know, you go into an exam, your calculator doesn't work. And it's really irritating then if you get stuck, right? So what I'm trying to do is I'm trying to demonstrate how I can do this using like factorization, mental arithmetic, and just to show you that it is actually possible to do. Okay. Part B, find the sum to infinity. Okay, so the formula for the sum to infinity is a over 1 minus r. So a is 128, and r is 3/4, so it's 1 minus 3/4. So that's 128 divided by 1/4, and dividing by 1/4 is the same thing as timesing by 4. So 128 times by 4, we'll double it, 256, and double it again, 512. So sum to infinity will be 512. Oh, beg your pardon. In part A, I was asked to find the 6th term of the progression, wasn't I? A bit lazy there. So sorry about that. The 6th term is a times by r to the power of 5. So that is 128 times by 3/4 to the power of 5. Okay. And that probably is a bit too difficult, I think, to do. So that is 243 upon 8. Okay. All right. So I hope that was all helpful, guys. Good luck as you prepare for your exams, and I wish you all the very best. And if you found these videos helpful, please do share them with your friends.